This is NSAA 2021, Section 1, Question 57. So we're told that in the electrolysis of molten potassium chloride, at the negative electrode, potassium is formed, and at the positive electrode, we have chlorine forming. In the electrolysis of aqueous copper 2 sulfate, at the negative electrode, we have copper forming, and we're told that the masses of potassium, chlorine, and copper were measured, and that the same number of electrons were transferred in both of these experiments. And the question we have to answer is we have to rank the elements from the least to the most mass produced in our electrolysis experiments. So where should we start in this question? We need some way of comparing the masses of each of our elements to each other. And we sort of have something we can use in the question. We know that the same number of electrons transferred in both of the experiments were the same. So if we use that to work out what the equations are for our production of each of our elements, we can link them together and then work out the mass. So let's work out what the equations are for the formation of each of our elements. If we start with potassium, what is the equation in electrolysis for the formation of potassium? So we'll have a potassium ion with one electron coming together to make potassium. For chlorine, it's going to be the chlorine ion. It's going to lose an electron, and we're going to form our chlorine. But remember, it's Cl2. It's a di molecule. And for our copper, we have a 2+ ion, and it's going to have 2 electrons added to it to form copper. Now these aren't balanced, and we also know that the number of electrons has to be the same in each equation. So we can see we've got 2 electrons in our copper equation, but only 1 in each of the others. So to balance them out, let's times them by 2. So these are going to be our new equation. So 2k plus 2e goes to 2k, 2cl minus goes to cl2 plus 2e, and our copper one just stays the same. So using these equations, we can now work out the mass. So using our atomic weights, let's start with our copper. We know that the equation to work out the mass is going to be moles equals mass times our atomic mass. We can use the number of moles as our coefficient of copper here. So our coefficient this time is going to be 1. So it's going to be 1 mole equals the mass divided by the weight, which is 63.5. So our mass is 63.5 grams. If we do the same for potassium, this time we see we've got 2 moles of it. So it's going to be 2 equals our mass divided by 39. So our mass is 2 times 39, or 78 grams. And for our chlorine, we see we've got just 1 mole of it again, but this time we have to times our atomic weight by 2 because we've got 2 atoms there. So 1 times 2 times 35.5 gives us a final mass of 31 grams. And now we can rank them. So from least to most mass produced, our least mass is our copper there, our second is our chlorine, and our final is our potassium. So this is the order it goes in, which leads us to a final answer of C.